Okay, because we're using dynamic memory, when we're done with our program, we're going to have to deallocate all of that memory. So I'm going to create a function called Deconstruct and call it at the end of my main function. And so in the Deconstruct, I'll pass it the address to the head. And I'm going to create two variables within the function to hold the current node, which will be deleted, and then the next node. So I'm going to have two variables, one called current node and one called next node. And the idea is I'm going to set current node to wherever the header is pointing, and then I'm going to set next node to current node's next. So next node will be pointing there. And then I can go ahead and deallocate this node, free that memory back up, and then I can set current node to next node. So then current node will now be pointing here, and then I can set next node to current node's next. So the next node would now be pointing here. And then I'll continue by deleting current node and keep doing that until we have a null in current node, until we've reached the end of the list. So let's make our two pointer variables current node and next node. So when we hop into the deconstruct, we'll set current node to where head is pointing, and then we're going to loop while there's current node, right? While there's something in current node that it's not null, we're going to set next node to current node next. So current node will contain 3, and then next node will contain the address for the 4 node. And then we'll delete current node, which does not delete the variable again. It just, frees up that memory. And then we can set current node to next node. So now current node will contain 4. And then we'll go back up. We still have current node. So next node will be assigned current nodes next. So now next node will be pointing to the node with 10 in it. We'll delete current node, which contains the 4. And then we'll set current node to next node. So now current node has the node with 10 in it. And then we'll go back up. It's still there's still something in current node, so we'll set next node to current node next, which will be null. The 10 node has null in its next. We'll delete current node, so we're going to delete the 10, and then we're going to set current node to next node. So current node will have null in it. So then the loop will finish, and we are done deleting, freeing up all of that memory. When we pop back in to the main function after we've called deconstruct, we're going to go ahead and free up any memory that's being held by head, and then set head back to null. And then I can just go ahead and print my list just to show that there are no more nodes in the list.